last weekend turning your homework. I've got some in the class, to be honest, who haven't been turning in things lately. Guess what? They're fixed up. I'm not fixing that. They got to get their life together and turn their stuff in. I'm not their mommy. They took an AP class. They knew they were going to have to do work in an AP class. They're not dumb. They know what their grade's going to look like since they haven't been. Surely they're going to get it together soon. One would pray.
Miss Compton, are you okay?
I'm okay.
Usually you start talking like that.
I know. It's me. So we can stuff on my page. Make sure you have out a calculator, because I've got the best cheat in the world for you.
That I already know.
Probably that. I didn't tell you it last week. Because sometimes life is more fun doing things like
I
that.
asked the math genius to help me with the thing, the coloring thing, and he showed me the thing.
I can almost say yes.
Yeah.
To see if you don't actually know what it means, pressing that. Yeah. So, yes, I'll teach you that trick today. I don't like if you're in calculus and you have to learn a long rule for limits and derivatives and stuff, and then you learn shortcuts, and you're like, wow, life is so much easier this way. Words.
I guess I do appreciate it more.
Excellent, because Jane is a theater. Okay, I will make you mine. In fact, here. Give me more paper. You can handle it. Okay. As for the coloring page, if you've not got it done today, which you should, but if you've not got it done today, for the love you need to turn in tomorrow, surely you're not working on it now while I'm talking. Because that would not be right, would it? I've got at least two who are, and one on his phone, and Louise wants to know why I'm stressed. Okay.
I'm checking my answers.
Okay.
Oh, there we go.
Yeah, it's too late now. Let it, Louise, I'm going to need you to put the stuff up before I start hitting math. Okay, then. Okay, bye. Okay. Whew. Air. Last week we were talking about z-scores. So basically, chapter 2, the big things we discussed are that empirical rule with the specific percentages that you should know, and then how to deal with a z-score. Now, the good news is that that's really, we have a little bit left to do, but that's really all we have to learn in chapter 2. So that's why you have so many things on your desk. So let's go over the different stacks of junk on your desk as to what they are. And so no one gets confused about what else is due. So let's pretend that Louise has turned everything in so far. Everything in chapter 1. He turned in his project. He has in no zeros. He has his life together because he's in an AP class. Woohoo. He did his coloring page over the weekend. He saw that I posted the answer earlier. He already checked. He knows it's great. He's turning it in. It's awesome. Then he has new handouts on his desk. Okay. One new handout is the test review, because there's going to be a test at the end of the week. One new handout is the test review. Now, the cool thing about the test review is that I also gave you the key to the test review. So notice the key is there. You have the key. It tells you the answers. So I would look over it tonight, and then if you're stuck on number 5, you could ask me tomorrow and we could work through it. But otherwise, we should be pretty good on this. I pray. But if not, just let me know and ask me tomorrow or Thursday. Now, I wanted to say the test was Friday, but the truth is I'm not going to see most of your faces on Friday, as is how life goes. So if I'm not going to see your face on Friday and you need to start the test on Thursday, that is fine. But the test has to be wrapped up pretty bow at the end of class on Monday.
So we're going to have class on Monday?
A few minutes. I can give you up to 20 minutes, but no more. I can give you half the class. Half the class. No more. Not the whole class. So, notes. Huh? If you're not here on Friday, then you're going to want to start it Thursday or come to 0 period Friday to get a head start. You could do one section. You could do just the multiple choice, or you could just do just the free response, but there's no way on Monday you could get both done unless you're moving way too fast, which is not what we want. Okay. I still have some who haven't taken / finished the chapter 1 test. God bless their souls.
Sorry.
God bless their souls. Okay, I also gave you, I'm a little late on handing it out, multiple choice questions for this chapter. Now, I know Miss Collins has handed out too many things. So if I were you, I would just focus on the test review. But I wanted you to go ahead and have the multiple choice for this chapter the way you did for chapter 1. But unlike chapter 1, when we called it our math workshop, because that's what we're calling our bell ringers now. I actually gave you the key to this as well. So if you look on the end of that other document that was stapled for you, the answers are there as well.
Are these being taken up with grades, or are these just kind of like a review for us?
Review for you, please don't, the review is something I would for sure do, and then these multiple choice, please God don't lose, because eventually my plan is that we have free time in April and May that we can review this kind of stuff. We could go back over these.
So then that makes it as grade. Just kind of
No, not for now. We might take them up in April, but no, not now. Okay, but, I mean, if you're really wanting something to make you feel better about your life, this would definitely be a good one, because, like, number 20 specifically says empirical rule, so you're like, oh, yeah, I can do this. I got this. So, bless you. So, there are a lot that will make you feel so much better about your life. So, there are those. Now you have handouts of the world. We will gladly review any of these tomorrow that you want. Tomorrow is also a Frappy Day. So my plan is really to review tomorrow and Thursday, but my band people have got to probably start the test on Thursday so we can review half the class on Thursday. I'll give you your Frappy tomorrow. And we'll actually spend more time on how I'm going to grade the next Frappy, because you're not just going to get points for if you don't do context and such, as discussed the other day. Okay, so does anyone have something they worked on the coloring page and they're stuck on something? They genuinely tried and they're stuck on one. You want to ask me about one?
We just go to number 8, like that light brown thing.
You're going to see your stuff.
Not your answer on it, but I just need to see it.
Okay, so she asked about number 8, which is light brown. Okay, the cool thing about statistics is that this lady made a key, I made a key. Sometimes our answers are a little bit different. So I got 92.36, she got 92.34. It's okay that we're that 0.02% off. It's going to be okay. So I saw it said normally distributed. That was my first key thing as to how I knew I could turn it into a Z-score. And it said that the mean height was 15. And they want to know what percent are at most 15.5. So I take, in our Z-score, if you remember, it's x minus x bar over that standard deviation. So it's going to be 15.5 minus 15 over 0.35. When I did that calculation, that's how I got 1.43. And see, hers, she did accidentally backwards, so that's why she got positive 1.43 instead of negative 1.43. What percent are at most 15.5 inches tall? So we're wanting everyone who's shorter than that. They are at most 15.5. X minus x bar. No, you were correct. It was supposed to be positive 1.43. I don't know why you wrote it that way. It's confusing me. Okay. So I got z equals 1.43. Yes, I am. She doesn't care. Okay, so I got z as 1.43, so I'm going to write a different curve than her because I didn't get negative 1.43. I got positive 1.43, which makes sense because our mean was 15. They asked us about 15.5. 15.5 is larger than 15, so we should be above the mean, above that 0.
I think that's where I got confused. Like, that whole, which way? Okay, so 15.5 is obviously bigger than 15, but like 15.5 is being subtracted.
Yes, so again, I'm assuming what you're doing, no offense babe at all, is you're probably messing up that z formula. Did you do always x minus x bar divided by the standard deviation? I'm sure you divided by the standard deviation each time, but did you, when I looked at your work, you did x bar minus x, not x minus x bar. You take whatever number they gave you and then subtract off the mean.
So the number what they gave us was
0.5.
Oh.
And then the x bar, it said mean, so that's why I know x bar is 15.
In my mind, I'm not giving that first number.
No, it tends to be. In fact, on most of these problems, it tended to be the very last number they gave you was the x.
Okay, so 15.5 minus 15 is that.
Yes, and that's how I got positive 1.43, which is why yours is going to be shaded. Well, that's why yours was going incorrectly.
Behind it.
Yes, so instead of being it says what percent are at most, they're all going to be shorter than this. So then I can go to 1.43 on my z table and say 1.43, that's 0.9236, which I translated to 92.36%, and then she had 92.34%. There's going to be surrounding error in life. They tend to be pretty nice about that. Pretty nice. Not always the nicest. Okay, are there any other questions from the coloring page before we go back to the notes and make your life so much easier? Okay. This thing is due today. And if you do the new way on this new thing, I'm going to take off. Okay? Okay. Unless you did it before you knew what I was going to say, Hunter. Hunter's the only exception to this rule. Okay. Last week we were talking about how to make life complicated. And I asked you if you knew a calculator button for z-scores. And we talked about how to go to stat and then test and then z-test. It's not bad. It's not bad. But wouldn't you and I rather... I mean, surely they've made calculators that can actually do what we were trying to do on number 5, like regions in between. So that's what we're going to learn how to do today. Yay. Yay, cheats to life. So, and I don't know your buttons, Louise, and I'm sorry for that. Okay, so, yeah, it's going to be, okay, so there are 2 buttons we're going to press today. One is normal PDF, and the other is normal CDF.
Are you ready?
And one is for a probability density function. DF's for density function. That's what we've been talking about lately. The other is for a cumulative one. So that's going to be if they happen to ask for just, that was ugly. If they happen to ask for just one little region, one side, you want a PDF. If they're asking for something in between 2 z-scores, you want a CDF. So CDF is when there's 2. Like you're wanting between 2 values. Okay, Ms. Compton, that sounds great. How come we didn't notice that button on a calculator the other day? It's not actually under the stat button.
Under distribution button.
It's under the distribution button. But you have to actually press second distribution. It's in blue.
Bars. No bar.
Yes, it's on the vars key. I understand what you're saying now. It's on the vars key. So you can press it and then do normal CDF or normal PDF. For instance, on that problem, Olivia, we were just doing on the coloring page, our z-score was 1 point what? Do you still have that out?
Yeah, it was 1.43.
And didn't we get 92.36?
What does it say under the calculator?
Ooh, that could,
PDF is switch.
okay, CDF is if you're wanting to do 2, like between a range. Okay, so I did variable, second distribution, normal PDF, 1.43. I want to calculate, and they gave me that, but ours is 1 minus that. Again, back to you have to know things in life. So it should work out. It should work out beautifully, and it should be a nice cheat for us. Do I normally use that? Yes, dear. Yes, dear. Do I normally use that? No, I'm old school. I like the table. The table makes me feel comfortable. I know that makes me old. I'm sorry, I like the table. But if we're in a hurry and we're trying to do like problem number 5 that we got really mad at the other day, doing normal CDF is definitely going to help us out. And I actually posted a link to this on Google Classroom if you're interested.
These things, like this little one greater than
Oh, yeah. So,
like the bolt buffer.
How do you get to it?
second distribution, which is vars, and then CDF or PDF. I did PDF just to show an example. So let's go to our notes and we'll actually work one. Be live. Okay, so let's see. Let's actually go to 6A. We're going to have to convert to a z-score first, but we can. So there's some example about Wimbledon and tennis. And this guy, he did 120 when on average Nadal normally does 115. So I'm going to do 120 minus my average, so minus 115, and then divided by my standard deviation, which is 6. Because it was in the problem, 6A. And then it said average, so that's why I knew that was X bar. So I'm doing 120 minus 115, and then divided by 6, and I got 0.83 for my z-score. Are there any questions about the 0.83? Okay, so I draw me my normal little bell curve, and I say this is 0, here's 0.83, and they ask, and I read through the question to see before I start shading stuff. It says, about what proportion of his serves would you expect to exceed? So they want greater than this. So on my calculator, if I go to second distribution, normal PDF, and type in my z-score of 0.83, yes. I don't mess with the mu, I don't mess with the sigma. We know those need to be 0 and 1.
Can you show us on the calculator what you're typing? Yes.
Second distribution, normal PDF. I typed in 0.83. That's the only thing I messed with was the X value.
Wait, what is it?
23. Second bars.
Second bar.
Yeah, but like,
What kind do you have?
actually,
Yeah, can you?
when I click on it, it just has like the, you know, you put it in parentheses. Is that same thing? Can I just put 0.83 in there?
If you do that, you're going to comma 0, comma 1. Okay, bless your heart, Sally. Can you write on your calculator? You're going to need to press, yes, press the same button, normal CDF. But you know how mine had a nice list? Yours doesn't. So you're going to have to type in the 0.83, put a comma.
But I thought we were doing PDF.
Oh, we are, sorry. Life. 0.83, you're going to have to write it, comma 0, comma 1. You actually have to write it in your calculator. Okay, so the 0.83 was our z-score. The 0 is for our new mean. Remember, we've centered everything back to a new mean of 0. And our 1 is our standard deviation. And you have to, if you're doing z-scores, put that mean and that standard deviation at 0 and 1. So with CDF, your life is still going to be complicated. So bless your heart, you have to put things in parentheses.
Is it the same thing for CDF, the same order?
It's for CDF, since there's two numbers, like if you're wanting between, let's say, 75 and 83, you would type in the lower number, the higher number, and then yes, the 0 and the 1. Bless your heart, the rest of us have a nice pretty list, and we just type it in the pretty list.
The higher number and
And then 0, then comma 1. Yes, dear? Say words.
If on mine at least, you can skip the whole PDF part by going
Do you have an 84?
84 plus something.
Yeah, it's because she has an 83. It's an 83
She has an
issue.
83.
Yeah, that's why.
I'm just saying I didn't
I
have
remember
to use,
because
I could use CDF
at the end of
and skip the whole Z-score process.
Okay, so, and then that's another suggestion that there is in life. So if you don't want to normalize stuff, first of all, they're looking to see if you normalize on the test, so I'm not sure that's a great idea. But if you're not going to normalize, he knows a way to skip that, and we can go over that in a second. But hold on, let me unconfuse Sally. Sally. Okay, bless your heart. On our calculator, when we do second distribution, normal PDF, we have a nice pretty list. You don't have a nice pretty list, but after I press paste, then mine finally looks like yours. 0.830,
I remember at the end of Alfred Tier Trade, Ms. Andrews had us do some stats, and I remember having to do that on my calculator.
Okay. Okay, good. That makes me feel better. Okay, just type it in the list, put things, the commas, and then 0, 1. Everything's 0, 1. Okay, so Hunter knows a trick. You want to tell us your trick? It's useful.
You go basically what you were about to do, but instead of going to PDF, you go to normal CDF. And for example 6A, for the lower, you would type in 120 because it's asking how many would see that. If you're upper, you could just type in like 1,000.
Just a really big number.
Yeah, just a
And
huge number.
If you're going in the opposite direction, you could do a really negative number.
But do you then change your mu and your sigma to then be the 115 and the 6?
Yeah, I changed to 115 and 6.
Okay, so, and this is not a bad idea, but if you do that, you realize your calculator is not normalizing for you, which is great. But my suggestion would be then, if that's what you do, which is what you're going to see tomorrow on the frapping, if you do this, you need to, on your paper, write normal CDF. Like, tell them what calculator buttons you press. That way they understand your calculator normalized it for you. So, yes, Hunter is physically skipping him calculating the Z-scores, but his calculator is now doing it for him. So
do I just have to write normal CDF?
normal CDF and then in parentheses all the things you typed in. So I would probably put like Sally's long list, normal CDF, 120, comma, 1 with 11 zeros, comma, 115, comma, 6. That's what I would put.
I don't get.
You would probably just get credit for writing normal CDF.
Okay.
Yes, dear.
Like, how does this this is more confusing.
Okay, to me and you, because we're creatures of habit, I saw it said normal distribution, I changed it to a Z-score, I go,
Yeah.
he's like, can I not, and make my calculator do it instead,
So we don't have
and
to
you
do that.
can. You don't have to, no, you don't have to do this. It's just his way of skipping, making it into a Z-score, which is not a bad idea. I mean, there's still a potential that me and Olivia, we make typos. We're perfect. We're not perfect. We're perfect. We're not perfect. The calculator is more perfect than us, so maybe it is a smart idea to let the calculator do the Z-score instead of us.
So what's the point of the upper again? Like, what was that?
It's trying to figure out a shaded region. So back to with CDF, it's saying what if we were going from here all the way to infinity? So that's why it's putting a really big number. That way it's trying to give you the area under this curve from 0.83 all the way for forever. But that's why you put lots of zeros so you can get a really good approximation.
Basically for between.
Yeah.
The upper and lower have a purpose.
Except the upper and lower have a purpose this time. So it's really not a bad idea. So if we steal his magic, which is smart, and we press things, we still get the same sort of values. It's just a little faster. So if we were to use his logic, it says what proportion of his first serves would you expect above 120? We got 0.2023, which is what my key also has. So it's not a bad idea. Okay, so he did it with CDF.
Wait, why is it different?
Again, if you're doing it with CDF, it's saying from 0.83 on to infinity. That's why we put in a really big number, like one with a bunch of zeros. And it's giving you the area under the curve.
I didn't get that doing that with PDF. Though. I got like 28269.
Okay, so same. So back to there's some rounding error, and were you and I making a rounding error? His way is technically giving a better approximation.
Wait.
His way is finding a better area under the curve than our way is. So should we do it his way?
Maybe.
Maybe.
I mean,
There's nothing wrong with converting to a Z-score and using the Z-table.
That's off by 8% though.
Yeah,
So,
I just use it because I mess up doing the Z-score math a lot.
it is off by 8%. If I had been old school and used my table, what would have happened? Let's see. Old school, use my table, 0.83. Again, I love y'all dearly. Y'all act like, I know statistics, but I'm not a genius. 0.83. So I'll go to negative 0.83. 2033 if I use the table. So our calculator is not quite the same either. So again, Miss Compton is old school. I use the table. So instead of going to positive 0.83, I understand that this shaded region is going to be the same as negative 0.83. So I went to negative 0.83 on my chart. Negative 0.83 was 0.2033. So I'm still a little off.
How does that work off? Like, how can it be off? You know what I mean?
Well, the table is not perfect. The calculator is more approximate.
But what about the PDF? Like, why did you get such a thing for the different numbers?
That's a really good question. I'm assuming it has to do
What with the rounding?
probably with the rounding,
Divided by 6, so it's like infinite decimal. Maybe.
probably with the rounding, and then, we might, back to Ms. Compton's going to pretend like I'm super familiar with PDF, and I'm not. PDF might be telling us the exact value at just 0.83. It might not be doing 0.83 onward. So that might be where we lost that 8%. That would be my only thought, which is not a very good one.
How does that make sense? That would be 20%.
It would make sense to go it wouldn't make sense to increase.
So that will make from the center, maybe?
Okay,
20% from the center.
okay.
And that's
So-
20%, that's as good as kind of close to 50%, but even so.
So moral of the story would be, if we had to make a moral of today's story, it would be either that I love the table, or you make everything a normal CDF issue. I swear I'm going to have to go read up some more on what's going wrong with the PDF, but I agree with Mackenzie in that CDF is doing a better approximation, and I think it's just because it's doing a better job of finding the area under the curve. But why wouldn't PDF? I don't know. I got to read. Okay.
That would technically be wrong if I gave you that answer in like 2 points.
Yeah. Oh, I agree. Well, if you had some work, there's still potential for you if you've got some work showing your calculations, how you know, back to me, I'm old school. I showed me calculating the z-score. I showed me making my normal curve and shading. They're going to give me some points for that, even with a bit of a rounding error. It might not be all the points I wanted, but it's enough to not cry. Okay, so Hunter makes life super easy. On this next one, which reminds me of the ones on our coloring handout, I would have done 2 z-scores. I would have done a z-score for 100. I would have done a z-score for 1 of 10, and then I would have found the area between the curves. I'm making life complicated. I don't have to do that. I can go to second distribution. I can go to CDF. Good grief. My lower can be the 100. My upper can be the 110. My sigma and my mu are still going to be the 115 and the 6. I can still paste, and I get 0.196, which is 19.61%. But again, if I just have this on my paper, it's probably not going to be enough. I've got to somehow tell them I did normal CDF and at least put what thing you typed. Because otherwise, yes, your number is right, but where on God's green earth did you get it? Stats is about defending yourself. Where did it come from?
You put that value thing at the top, you put 100.
Yes, so on my thing, normal CDF, I typed in 100, 110, my mu was 115, my sigma was 6.
So why did you put in 110 for upper? That's like the most you could do.
Because they gave me between 100 and 110, so that's why I did 100 and 110.
So how do you know when to use CDF or PDF?
I'm going to use CDF every single time. I agree with him on that. That was a better approximation. But you and I would have said, if you and I had drawn a table, something about average was 115. One person was down here at 100. One person was here at 110. They want to know between 100 and 110. You and I would have made it complicated. We would have turned them both into z-scores, used our z-table to find the area in between. That still works, but it's slowing us down. With his way, if you type in the lower, you type in the upper, it'll tell you the area under the curve. So on the other one, our lower was 0.83, but our upper was just a really high number, basically trying to go to infinity. So we could,
6 for that O thing. So that O thing means
the sigma, that's the standard deviation. So we could even, if we were having a curve that looked like this, and they wanted to know from here below, our lower, we could do a negative really big number. Our upper, or this could be whatever the number was supposed to be. Maybe this is the 100.
So does the PDF and CDF work if it's not symmetrical?
No. So back to, and this is your major point in life, which is something that I need you to remember for the rest of the year, is that all the junk we've been doing only works if it says in the directions something about standard, normal. It's got to say something about it being symmetric, because if it's not symmetric, none of this junk works.
Okay.
Because our symmetric stuff is assuming the area under the curve is a specific way, it's skewed a specific way, it's centered. The tails match, and if it's skewed, the tails don't match.
I didn't think it would. I was just asking.
No, that was genius. Okay, the fastest 20% of Nadal's first serves go at least what speed? Can we get through 8C without crying? The fastest 20% of his serves go at least what speed?
I'm gonna try to do this.
Okay, well, let's, I mean, how are we going to do this? I mean, I don't know. We're wanting to know what this top 20% is. But how do we figure out that the area is exactly 0.20?
It's going to be just a little bit past half of 68. Wait, no.
So he's trying to empirical rule it, like Louise was trying to do the other day. We don't normally let that go. Empirical only helps with the 68, the 95, and the 99.7. 100 minus 95 is 5. 100 minus 68 is 32. So asking for 20, it's one of those. So how can we find this? What are we technically going to do?
Would we have to do it basically what we did in reverse?
Yeah, so that's exactly what my note's going to be to myself, is that we're going to do this in reverse. So our table has percentages, right? And this is why I like my table. I like to hold it, I look at it. If we can do this in reverse, we know the percentage, let's find it on the table and then figure out what z value corresponds with that percentage. Okay, so let's look. Where do you see, and should we be looking for 0.20? What should we be looking for under the curve?
Look for 0.2.
Look for 0.8 because it's that way.
Yeah, so we need to actually, if we're going to, or we could use the negative version. But yeah,
Because then that wouldn't make sense, because then it'd be the lower numbers.
it'd be the lower 20%. But it was the z-score would be, instead of being negative 1.4, we would pick positive 1.4. We could just invert it, the sign of it, in my mind. Okay, so again, the z-table is shading in this region. So we need to actually find 0.80 in the z-table to help us figure out the inverse of that, which is the 0.20. So on your z-table, we're looking for 0.80 something. As close to 0.80 as we can get without really going over it. So, like, for instance, I see 0.84.
0.8023, is that to the right of where your finger is?
And that's going over it. Isn't that technically 86 degrees? So we don't want to go over.
But we want as close as we can.
We want as close as we can get without going over. So you would want to pick 0.85 in your mind. But really, we got to back up to 0.84 because when we do that 0.8023, it's technically gone over 80%. It's 80.23. So we're going to pick the 0.84 as our z-score. So our z-score was 0.84, which sounds great. That doesn't help us with our problem. How do you calculate a z-score? Where does the 0.84 normally come from? What's the formula?
X minus X bar over standard deviation.
Okay, so we've got to figure out the x minus x bar over standard deviation. So I'm actually going to write it below, and I swear we just don't do the last one, or I'll write it somewhere else. So we know z is 0.84. We know x bar, it is what number? No, that's the standard deviation. We don't know the magic number this time. So we have to solve for it. So again, let me say we're going in reverse. For once in our life, we reversed it. We found the z-score first. So we've got to find that x. So 0.84 times 6 is 5.04. I got to add 115 to both sides. I get 120.04 is equal to x. Yes. So we're just going to say, again, back to, I think we should have, yeah.
Is that all the ones?
Okay, so let's say the words again. We did it in reverse. And we knew to do it in reverse because instead of them asking us for a percentage this time, they gave us the percentage. So that's why we realized it was reverse, because we were given the percentage. We converted it to a z-score. We've got to find what that x is, so we solved our equation. We got x is 120.04, and we just rounded down to 120, because you don't say I went 65.7 miles per hour. You say I went 65 or I went 66.
So is that, like, do we need to change anything because it's going in the opposite way of what they're asking? Does that make sense? Like,
Well, the fastest 20% go at least what speed? So we would say the serves go greater than 120 miles per hour. So that's crazy. His fastest 20% serves are greater than 120 miles per hour. And then I'm technically in trouble right now with my sentence. What is wrong with my sentence?
You didn't relate it back to tennis.
I didn't relate it back to tennis. So I need to say more specifically his serves. Is it specifically his first serves or just, yes, his first serves?
It wouldn't even make it the same game.
Nadal's first serves go greater than 120 miles per hour. And I know that's really stupid, and I get that life is stupid, but I graded your project, and it was just thrown in the little word like first serves rather than they. That the tiny, tiny little wording is what's going to get you in life and help.
Are we still doing these?
You're just going to get all 5s because you're awesome for today.
Wonderful.
I get how you did everything else and why you do it, but like I don't get where you got .8 from.
Okay, so I knew it needed to be, I went to my table and I wanted to find as close to .80 without going over. So on my table, and if I'm looking at all the numbers, you're like, oh crap, how am I ever going to find this? And you start looking, and there are a lot of 7s. Oh, there's a 7-9, I'm getting closer. 7-9, 7-9, 7-9, oh, too far, .82, 023. So I've got a backup one.
So I thought we were doing it in this. I thought you did .84, and then it would be.
But that's where I'm getting the .84 from, because .84 is where that .7995 happened, which is as close to 80% as I could get without going over it.
So why were you looking at the numbers before you did the?
Because on that one they gave us a percentage first. And in fact, there's a previous one that we skipped that was just like this. Let's look at number 8. We skipped it, and let's go to it now, because it's the same sort of thing. It's a reverse one. So we're working in reverse. It says specifically that we want to know his scores. It says the distribution of test scores is approximately normal. Joe scores in the 85th percentile. How many standard deviations above the mean did he score? Since they gave us 85th percentile, they're telling us he was at the 85% mark. We need to go look on our table and find .85 without going over. So has someone found it? I think it's 1 point something. I think it's 1.03 because 1.04 is .8508, which is a little over, so I would go with 1.03. But I seriously think you're going to get credit for either one of those, 1.03 or 1.04, because the lady I'm stealing notes from, she did 1.04, and she knows what she's doing, but technically isn't that over, so. Staff has a little too much leeway. Yes, it is, but in my mind, the second you go over, you can't use it. Like, you have to back down one, like a step function. Like, you must back down one.
Like 0.5.
Yeah, like pick whichever one's 0.5 closest to it. And if you're going to stick to that rule, that's fine. But in my mind, like a step function, I always back down. Is that bad of me? Probably. Okay, so again, I'm looking for 85. I see 84.85. I see 85.08. So that's when me and Louise are having a debate as to which one to choose. I say go with the one that's almost there, but just a little lower. He says that one's a little bit closer to 0.85 than mine, so he's going to go with that. But since I'm picking this one, I look up, I look over. That's why I'm at 1.03. That's why I know I'm at 1.03. Does that help? And that's the Z-score. And the Z-table is all about the Z-score. So we've got our Z-score of 1.03. And now they ask us how many standard deviations above that did he score. So if I should have just drawn a table to begin with, that would have helped. So this guy, this is him. His name's Joe. So Joe is 85% above most people. Good job, Joe. So how many standard deviations above the mean did he score? That 1.04 is going to work for us. because the z-score does tell us how many standard deviations above the mean. So he's a little over 1.
Why'd you write the board video down?
Oh, it's for 5th period because I said some things that were from somebody else that I should probably take down. Like I used someone else's handout real fast, and I should probably pull it down until they come out. You know, it's like when you go to, anyway, I'm incriminating myself now. Incriminating myself. Okay, we're going to skip the IQR one.
Oh, it's okay.
So number 8's done.
We're going to call it a day on number 8. Or we're going to call it, yeah, number 8 was done. And we're going to call it a day on the example with Nadal. Yeah, the 1.03 was good. Okay. And then our last thing to talk about today, and we're not even going to do all the things, we're just going to basically talk about it out loud, which is what we were supposed to talk about. The whole point of today is this last little bit. Whoops. Which is really what Jackson was saying. How do we decide? Like, great, normally distributed, maybe I can use the empirical rule, maybe I have to use a z-score. How do we decide if it's normally distributed or not? Okay, how are we going to find out if it's symmetrical? What are we going to find? What are we going to make?
Graph. Then
You can create a histogram, yes. What would I prefer you to make in life?
Box plot.
Make you a nice box plot. Okay, you want to create that and see if symmetrical. Or mound shaped, or whatever word you want to put there. And then it would help you to see the words. And then it really wouldn't hurt if you checked to see if it followed the empirical rule. Like to check a value and see if it was 68, 95, 99.7. Okay, let's say you don't want to do this. Let's say you're lazy. That's a whole lot of values. You just don't feel like it. Your other option is to create something on our calculator called a normal. Create a normal probability plot. And you look to see if the plot is linear. Then your data is approximately normal. So just like Hunter figured out, there's a cheat for figuring out the z-scores quickly or figuring out stuff without even him calculating z-scores. There is a faster way for him to decide if something is actually approximately normal or not, rather than making his own handmade box plot. So if he were to make his own handmade box plot, for example 7, which has to do with some refrigerators, woohoo, he would have found it looks kind of normally distributed, but you're really not sure. That left whisker looks a little longer than that right whisker, so you're kind of wondering if it's skewed a bit. But, I don't know. So, you're just not really sure. So, instead, you could do a normal probability plot, and you could look and see, and if it's linear, your stuff would be linear. And here, if a normal probability plot is skewed right, it looks like that blue line. If it's skewed left, it looks like that other blue line. So let's make a normal probability plot, but I don't think we have time to type in all those values. So if you go to come on.
Okay, so the stuff that you're reducing the chapter homework, does that mean you don't have to do all of them?
Yes, and let's go to that. If you go to stat plot and the last button with the linear stuff, that's what you could use to help you figure out this normal probability plot. And I'll post a link that better clarifies that later. Let me go to what she was saying because I'm going to forget all about it and it's going to break her heart. Okay. Tomorrow and Thursday, I want to just practice. I want to practice the multiple choice problems. I want to practice the frappies. but some people are going to have to get started early on their tests. You originally were told you had to do every single problem in Chapter 2, but again, I'm a sucker. I'm going to say you only have to do 30 out of the problems. I would say don't do any of the transforming data problems. I would say I would do these 7, these 9, these 4, these 11, and that technically adds up to 31, but I'm only going to make it out of 30. So if Olivia wants to skip one of them, she can. It's not even going to be due until next Monday. And if I'm telling you the truth, there's potential that I might not be here next Monday. And if that's the case, you lucky dog, it's not due till next Tuesday. But Olivia doesn't want to bank on that. But my absence is pending.
I literally
Do you need a sub? My grandmother can sub for you.
I already have a sub.
Why?
I can sub.
Because I pressed the button and I needed a sub, and the person already emailed me back and said they were subbing.
Well, then you're gonna be gone.
No, I'm going for the half day.
that
Do you really want to know my whole life?
Yes.
when it says non